And sharing the screen. Oh, yeah. Oh, I forgot to do keywords. Well, I'll fill those in later. Okay, so usually we put the date here. I seem to have forgotten to put the date and the keywords on mine, but you'll see everybody else has those. All right, so mine is also a little on the short side this week. So typically at these things, I guess I'll explain. So we all kind of take turns presenting on the kinds of research that we did that week. I also tend to like to include a few slides on sort of relevant lab news, which you're welcome to do if there's a story or something that comes across that you think people are going to be interested in. You can feel free to talk about that as well. So this was, I'm always keeping an eye on technology. So this is the Autel Alpha, which looks like it's going to be incorporating some very nice cameras. So a 48 megapixel camera, but also thermal and also a laser rangefinder. The laser rangefinder, I wish, was standard on more things because you can use that, for instance, to do better terrain following than you can do from just like the DEM. So when we were in the Solomon Islands, DEM resolution is 30 meter. And as the terrain is much more rugged than that, the terrain following was a little dicey in some places. It would get a little bit too close on the ridges, and it would be a little bit too far away for the LiDAR to operate correctly down at the bottoms. So better terrain following would be really great. This is just a reference to the segment anything algorithm in medical imaging that I had talked about a little earlier. It's always useful to be able to dice your images into different classifications, and the segment anything algorithm has proven to be quite useful. This is just one interesting application of that. I expect that this kind of technology is really going to transform. We're going to see some big changes in diagnostic quality over the next decade for sure as a result of this kind of thing in medicine. This is one for Liam. So Liam gave me the coordinates for the archaeological site that he was looking at last week, the one that had been imaged with LiDAR, and then they had found all these connected subregions a lot more dense than they had suspected. These are the coordinates rounded to the nearest 100th degree here, which was close enough, and it's overlaid on top of one of the runs, the least cost path runs from Colleen's work. So she was connecting different places along the Inca Road, basically trying to see how well a least cost path would mimic the Inca Road connection, the actual Inca Road connection between sites. So she had one in Proaño. Are we in Ecuador?
Yes, I believe we should be.
I think so. So she did have a lot of connections that were nearby. So she didn't have this one that you looked at, Liam, but she had stuff that was very, very close. So it was cool to be able to see how that site relates to Colleen's work. So yeah, it was neat. I've spent a lot of time in the last week sort of prepping for the Guam trip. We're likely to leave on March 3rd or so for the LiDAR scan at Guam. We're going to be flying the Alta X, which is in the foreground there. Basically just kind of going through everything to make sure that it works since the last time. We haven't flown the Alta X since August, I suppose. Just wanted to make sure that everything was working. We haven't run the LiDAR since we got back from the Solomons. Wanted to make sure all that was working. I think last time we met, I had still not finished transferring it onto the new mount, which is now done. Everything went really smoothly there. System seems to be working fine. I did an outdoor test with the LiDAR. That looked fine. So this afternoon, or more probably tomorrow, I'm going to take the Alta X out for a quick flight without the LiDAR just to make sure that everything is running. And then if that looks good, put the LiDAR on it and start gathering data. And if that all looks good, then I can pack it up again and it can be safely put away until it's time to go. But that'll be a load off of my mind to know that all the equipment is running. A lot of random stuff. I bought a DJI Avata a couple of weeks ago. I mean, I bought one a month ago, but that one had some activation problems. But the Avata is now registered and flyable. I flew it a little bit inside. I haven't taken it outside yet. The weather hasn't been awesome and I haven't been feeling well. I got a new mini PC for the large touchscreen in the lab. So we used to connect this screen to that computer. Now we don't have to. We still can. But that gives us some mobility about how we can move things around. It's it's the new Intel graphics cards are pretty good. I think it's a little bit laggy for the Google Earth touchscreen at 4K. So we may end up having to hook it up to a beefier laptop or something if we want to do something more interesting than just PowerPoint presentations. But that's fine. I'll be happy that we can just we don't need to dedicate a computer for lab meetings. I got the GoPro Hero 11 set up. We put a 256 gig SD card in it. We've got the media mod. I guess I didn't put that on there. I got the GPS time sync set up. This is partly because Jan Chao and I were talking about GoPros last week. So I was like, I better get this thing out of mothballs and get it running. And then we got a DJI Mavic 3T drone, and it arrived. We're going to fly it today for the first time. I don't know if I'm going to be there. Hey, Peter. Hi. Over there. There's one hiding over there. And then Adam Matthews also got a Mavic 3M multispectral. So that one's still in its box. So hopefully that'll be online and ready to go. So lots of new good equipment to play with, including we're playing around with the little Topcon is a LiDAR company, I think. This is like a little handheld. Yeah, so I've got a couple of use cases for this. It does have an SD card. So in addition to sort of just like, running things around and scanning stuff, you can take pictures with it. So pull the trigger and you get a picture and then you can save it. So that's pretty cool. Today I want to see if we can make just like use Microsoft Ice that's stitched together just like a facade image or something easy. What else was cool about this? So that's neat. And then I got the same thing for the Android and played around with that a little bit, got it out of its box. Yeah, so good stuff to play with him. Have fun playing around with that a little bit there. It's pretty fun. Yeah. So the two use cases that I have for this one, well, I guess three. The one, I don't know whether it's going to work or not, but it's got a perfectly good thermal imager. The only problem with it is it seems to basically do like a screenshot. So it doesn't, like, I'm not expecting like a radiometric image or anything, but it like overlays like, symbols over it with like the highest and lowest temperature and stuff like that, like the color bar. I'd like to be able to strip that stuff out, and I can on the Android version. So I'm hoping that there's a setting for that. So that's first application. Second application is thermal GCPs. So if we're out in the field and we're doing a drone mission with the Mavic 3T, we can use this to take measurements on the ground really easily. Easy piece of equipment to pack, easy to sort of write some stuff down. So I'm looking forward to that. And then third, just like demos, right? So like a lot of what we're doing is sort of like outreach, like you set up like a booth or something and you want to like talk about what you're doing. Like having a prop like that you can sort of give somebody is like, was only like a couple of $100s for that thing. And I think that's going to be worth its weight in gold, to like as like an outreach. Here's how this stuff works kind of a thing. Like it's super easy to use. Even easier than like the one that goes on the Android phone is nice, but you need an app and it's a little fiddlier, and like there's just something nice about a single encapsulated unit. Shashank, I know I still need to get you the behavioral geography stuff. So sorry about that. I haven't forgotten. I need to do, I did an indoor flight test with the Avata and Integra. I need to go outside and do it. I'm looking forward to that. I would do it, but I think technically you're supposed to have, you just, well, save the news, but
Yeah.
the, I think you need a spotter. Like if I were flying that thing FPV, I think someone else has to be observing it separately. So I need somebody to help me with that. Yeah, lots of other stuff. Some stuff has been going fine. I just need to kind of keep plugging away at the Guam and Solomon stuff. All right, that's it for me. Do you have a presentation this week?
Unfortunately, no, because I'm just so busy.
That's all right. Well, you want to share your big news with everybody?
Yeah, I passed the part 107 just yesterday.
Oh, that's nice. Congratulations.
Congratulations.
Scared
That's
with
awesome.
$175 price tag. I was like, I really need to pack this.
Yeah, absolutely. Well, that's great. Congratulations.
Yeah.
Yeah.
So, gotta put the orders in for all the license and the applications are. Yeah.
Right, to get you the card.
Yeah, get the little card.
Yeah, the card's cool.
Yeah, I can be like, I'm a pilot.
It's so good. That'll stand you in good stead for a long time.
Yeah.
It's easy to renew, even easier than it used to be. So, you'll have that in your pocket for a long time.
Yeah.
That's great. Let's do some introductions now that we have everybody here. Everybody knows me. Why don't we start with the remote crowd? Shashank, you want to lead us off?
Sure thing. I am Shashank. I'm a second year master student at Virginia Tech, and I'm working with Dr. Pringle on the build project, which you'll see some of in our presentations, where we are looking at LiDAR sensors to detect people moving inside a building space. So yeah, that's it.
Yeah, and I'm Addison. I'm also a master's student at Tech, so I'm in my last semester there also. And I'm working on the same project as Shashank, but I'm working specifically on looking at specifically how people are interacting with one another in the building. So I'll fill you in a bunch on that when I do my presentation in a couple minutes here.
My name is Liam. I am a senior or fourth year at Virginia Tech, currently doing a study abroad in Scotland. I'm studying geography with a particular interest in using LiDAR and remote sensing for use in archaeology.
Hi, I'm Dan Chao. I'm a fourth year senior at in the university, and I'm doing some stuff with LiDAR and photogrammetry.
Cool. I'm Peter. I'm a 4+1 student looking into thermal imaging with the Binghamton University Nature Preserve with deer populations.
Awesome. Well, welcome, Jen Chow. Thank you for joining us this morning. Thank you. All right. Well, I will we'll hand it over to Jen Chow then. Can he hastily put together a presentation this morning?
So what I did last week is about the Go and the GoPro to set up some photogrammetry and doing some testing around university. So my GoPro is GoPro 9 and installed with that firmware. And the mode I use is time-lapse photos, which allows take a photo every 1 second or every 5 seconds. But the 1 second for the GoPro 9 is narrow, but the 5 second one is wide. And it was processed into the Pix4D Matic and Pix4D Mavic. And the first one I took is at outside the union of the university. And total is 13 pictures in total, and with 1 second narrow interval with intervals. So that means like taking photo 1 second, but the photo is pretty narrow and not a really high resolution. And we
So I got a question on that. So we used the GoPro 9 and we were able to do wide on 1 second.
but
Yeah, we better look at that and see.
5 seconds to wide and 1 second for narrow. And
We better look at that. We definitely did every 1 second.
yeah, but I can't do that.
We'll look at it, we'll look at it, yeah.
Yeah, and the data set, the link can be found there. And the second one I took is at the University Nature Preserve, which is a map field. This one I took with 5 minutes, this is narrow by second. And I walk in with about 5 minutes, so it's 315 photos was taken. But when I process into the Maple and Matic, there are 6 photos cannot be calibrated. Maybe they're not enough overlap between photos and photos. So this one makes the whole data set a little bit disconnected. And it failed to process in the Matic since the prompt that the lack of the camera orientation metadata. So I processed in the Maple, but it takes really long, around 10 hours. And the mesh, the 3D mesh looks better than also Medak. So the also Medak tend to be a little bit not really clear, but the mesh turns there is pretty cool. The task number 3 is use 5-second interval and with wide mode. And this is the same way I turn back to the entrance. So it's only 60 photos taken. This is still on the process in the cloud environment. So, but I have the link with the raw data. So there's some problems within this process. Is the first one is lack of camera orientation metadata, which need to fail to process in the Pix4D Matic. And also some photo cannot be calibrated. This is another reason for it cannot be processed in the Matic. But another thing is like 300 photos takes too long for processing. My goal is like I got a new GoPro 12, which allows me to take one photo every 0.5 seconds, I think. And I will test into this in next week, and I will find out what's the noise and why the Matic cannot work with the orientation data.
So 2 things, yeah, so the Matic on the orientation data is an interesting one, I hadn't heard that. So if you can confirm that that's a limitation, I would be interested to know that. When we were doing our tests a few years ago with the GoPros on photogram, there's a lot of different names for it. Photogrammetry on a stick is one, full photogrammetry 2. I think that one's a little bit more common these days. I'd written a Python script that would add orientation information to the image based on the GPS track. So basically the idea was, you know which way the camera is pointing. So you could measure that, like with your camera, you could say, okay, the camera is pointed at 20 degrees off the horizon or something. You could do that, even if you make sort of a guess. Often good, right? You can infer the heading from the track, right? So as long as you're moving forward, then you can guess the azimuth from the GPS track. And then the other one is roll, and you can just assume that roll is 0 most of the time. Now those aren't perfect values, but no values are ever perfect. So as long as it's within the margin, then that can be used. So but what we found was that it didn't really help the reconstruction. So Pix4D Mapper doesn't require a orientation.
Yeah, it doesn't matter, but seems like the Matic takes short time.
It may, yeah. So confirm that Matic needs it, that would be good to know. But if it does need it, I mean, Mapper is probably good enough for this kind of work anyway. It is slow though, relatively speaking. One of the problems with this kind of image collection is you generate a lot of images, right? It's like if you're taking an image every second and you walk for 300 seconds, like that's a ton of images. Whereas most of the time when you're flying a drone, if you're going to do that, you're going to be imaging. You might still image every second, But more likely every 2 seconds is gonna be
Yeah.
plenty, and you're gonna be going so much faster that you can image much larger areas.
Is it level? Like, how do you make the camera level if?
It's a little bit down and it's roughly 20.
But like, are you the one holding it and like locking?
Yeah, holding it on one.
You
So
put it on a stick and
Yeah.
and then it kind of points down.
So like, wouldn't you miss like a certain amount of like overlap? Cause like human.
Yeah, definitely. It's like that's why some photos cannot be calibrated, so it means some photos get shaky.
Can you just like crop out like the area?
No, you don't wanna do that. It'll throw it away. But as long as, that's one of the reasons why people like to use poles, is the higher you get, the more overlap you get. If you're kind of closer to the ground, then like even a little bit of shake means you don't get the overlap, right? If you're just kind of like
Yeah.
walking along, you can. But that's one of the limits that we're trying to push. Like, it is kind of like that small pole, so we used a broomstick basically. Which is, we find is generally a pretty good height, like it's enough to make it work without being so much that it's irritating. Like, we've got a pole, that pole in the corner is like 30 feet tall. It's really awkward to carry. Like, you could do it, but like you wouldn't want to do it for very long. And if it's windy, like even a camera on the end of a 30-foot pole is like hard to manage.
Yeah.
So, yeah, we've done, I'll share some, we've probably done, I would say probably something on the order of 20-25 lab reports from the past couple of years have dealt with pole photogrammetry.
Mhm.
If you want to spend a couple of hours just like with
Yeah.
us in the past, you can see what some of the things that we've done are, and we'd be happy to share.
Yeah.
We've got some, one that we did, Barrett did some fairly, was it Barrett that did it? Barrett did some of it, and Grace Fernandez did some of it. These like systematically varying, this with the GoPro or that with the GoPro, this angle or that angle. So we have a lot of sort of data sets that could be mined for, without having to sort of replicate it yourself. Like, you're welcome to go out and do it all yourself, but like you could just sort of do it. Well, wonderful. Let's pass the torch on to Shashank. I'll stop the screen share here.
I guess you can see my screen now.
Yeah.
So this week, the major thing I did was we divided the data into sessions, and we were discussing about like how much annotation we needed, and we ended up with numbers. So the basic idea for now is to like spread the whole annotations for all our data. Because I'm going to be using these annotations to validate my results for the computer vision and the deep learning algorithms. So we decided that the sampling should be done from the whole fall semester. So 6 days will be randomly selected from each month. And for each day, 3 minutes of data will be like extracted, which will be like 1 minute from the morning session, 1 minute from the day, and 1 minute from the evening, resulting in a total of 5,400 frames. And I'm trying to estimate how much time it would take to annotate the 5,400 frames. So this is like a lot of data. So I did start with some annotations for the day session, but it's like whenever I look at the total image files, it gets dizzy after a bit. It's a lot of annotations, but like I think I should be able to do it like pretty easily. I'm estimating 20 minutes per each minute of annotation. But it's just an estimation, so I'll probably like know when I do it. When I set it up like to run the annotations yesterday, the keyboard in the lab like just broke, so I think I need to replace the batteries, and that's why I could like finish it. So in other frames, and the other thing I wanted to note was like I'm using Microsoft VOTT for the annotation. However, like some frames I'm using for the day session are from August, and there's like minimal activity in some frames. And with VOTT, you cannot have a frame that does not have a class. So if there are no people and I'm not annotating anything, it just does not let me export it. So when I'm done with an annotation for a frame, it gives me this green check. Whereas if I've looked at it and not annotated anything, it gives me this orange eye. So what I did to surpass this was like I created a placeholder class that's like basically just going to be a class that I'll remove later on. I'm just like selecting random things, just maybe clicking here and like calling it placeholder so that the orange eyes are turned into like green checks. It's just a workaround for like having to end it at least something.
Yeah, I'm not sure that's a good idea.
Yeah.
Yeah,
But
I think I think you should just like choose a different frame. Choose
so do you mean like,
a different minute.
but for the August data set, there's like whole hours without any movement, Dr. Pringle. That's
Yeah, but I don't think that it
so
does any good to train a model on no people.
that's true. So would you suggest like this would have like this would only be like I'll have to like look into all the frames if like I need people and every of like all of them would have to have people.
Well, I mean, if you think of it in terms of minutes, right? Like, I don't think every frame needs to have a person, but I think every minute needs to have.
Yeah, that's
Oh,
that's true.
oh, I see what you mean.
Yeah.
Oh, yeah, that's a
So
different.
so for VOTT, you need to like annotate something in each and every frame. So like the minute here like has some people like later on, but if a single frame does not have a person, I have to like annotate something, otherwise this won't export. So that's a problem for now. I was thinking like when I am able to like export all the annotations, I can just run a small script where I can get rid of like all the PH classes.
I
So this
suppose.
is a
Okay,
this is a yeah.
we better chat about that. Like, I think you should probably, I think you should definitely not do it if there's nobody in the whole minute, you know, which could totally
Mhm.
happen in August at 6 in the morning.
Yeah.
Like, you could easily get a case. So
Yeah.
I would exclude those. Let's chat maybe after the lab meeting and.
Yeah. That
Okay,
sounds good. Yeah. Yeah. So this needs to be looked at. Yes. So I was wrapping up the OpenCV algorithms and I'm like just able to run it with like a single function call. And this is like practically what I guessed. So for now, if I run this function, it gives me a place where I can input the video file, where I can explicitly call the output path. And one thing that we have to like say to the function is this is the first frame in like the date, time, and the like date and the timestamps, so that whenever I'm writing an output file, because the video does not have like embedded datetime format, and I'm trying to write the annotation uh, file as well. So this is where it gets the input and writes the output from. So this is an input that is needed for the by the users, and that's what the and like stream file name is written on. I've also added a frame counter so that it's like it just has basically a lot of things that I can like relate to later when I'm comparing the algorithm. And the same goes for the background subtraction and the frame differencing. I think I just put the same picture for both of them. And then I was trying to compare like how much it is differing by, and this is what I got. The one thing that like got my like attention was the number of detections. This is the background subtraction and this is the frame differencing. Frame differencing apparently has a lot less, like 4 times less objects being detected than the background subtraction. And I looked into the data set and I wanted to see like what's going on in the data. And one theme that like stood out was, oh my gosh, I think I forgot this. So this is what I got. This is one of the frames that I just like comparing. And what I saw was for the frame differencing, nothing is getting detected, while for the background subtraction, a lot is being detected in a single frame. And this happens for like multiple seconds. So what happens here is, as you can see, most of the things being detected are near the furniture. And background subtraction is pretty good at like looking at people near the furniture, like even though it's like missing out on some, but frame differencing, basically all of these are like chairs and people are sitting next to it, but for some reason frame differencing just thinks it is the background. And so I think these are the major frames that's like causing the major discrepancy in the object detection. So I still need to like look at this more detailedly. This is like just an example frame I had. Yes. So that's it for like the stuff I did for the annotations and the OpenCV stuff. I found this paper which I thought related to like our work by a lot. So this is basically trying to detect uh, changes in an indoor space using LiDAR data, the like similarly to what we are doing. The only novelty here is like it's choosing a entropy based method, and I was like just curious to see what they were doing. So they were also like looking at the indoor spaces using a LiDAR scan, and they just take a LiDAR scan and they just divide it into horizontal slices, and they were specifically looking for entropy in the LiDAR scans. So entropy basically is the measure of randomness or changes, I guess. And that looked very interesting to me. And I was looking at the different methodology they had. So this is what they do. They collect data, they slice it, and they calculate entropy using a function. And after that, they just they like based on how much the entropy was, they basically divide it into objects. So if there's no entropy, they call it unchanged, and like it's basically walls and furniture, walls and pillars. And structural change is like doors and I think furnitures too. And the other two are like basically objects that are moving. Could be people, could be small objects. So this is like looking at the scan, this looks like a scan from something like a Velodyne scan that we did in the past. So it's a radially outward looking scanner. And it's just the paper is just like talking about how this could be sliced into multiple sections, horizontal sections, and entropy could be used to detect objects. The paper does not go into very high detail. It's a short paper. So based on the entropy, this is how it sections the objects. I was not exactly able to figure out what they were doing because they just calculate entropy, and the pictures they've included look like they're doing a great job. So yeah, this paper looked promising, but I think I do not understand completely like what the entropy part of like object detection is. So that's kind of it from my side. I still need to like work on the results from the OpenCV algorithms, and we'll probably have to revise the frames for annotations as well. So yeah, that's it. The goals for next week include annotations and writing.
Thanks, Sean.
Cool. Okay, I will go ahead and go next. Let me go ahead and share. So I have a quick ish report today. I did a lot of stuff, but not all of it got reported. So basically, just as like a recap from last week, I had been trying to run my collision algorithm on basically 18 gigabytes of data all at once. And I had started that on Wednesday of last week. And I was hoping that if the time of like running the data set were to scale like linearly with when I ran it like 2 weeks at a time, it should take around 4 or 5 days to complete. So I was hoping that by the end of the weekend it would be done and that I'd like have all of my data. But unfortunately, that was not the case. So I pulled the plug on that on Tuesday. I had kind of come to the reasoning that the code was not scaling linearly. And when you're trying to process, I think it was 67 million points of data for all of like all of Percept data for the fall. I think it was 67 million. That it was going to take too long to like iterate through everything all of those times. So I had spent some time like talking to some of my friends about it who do a lot of work in coding and like asking ChatGPT and like Googling stuff like that. So I'd kind of come up with ways that I thought I could get the time down at least. So that led me to basically just like taking 2 small data sets. So the first one was 35 megabytes and the second one was 150 megabytes. So it was about 4.2 times the size of the first set. And basically I was running those through my algorithm and like making small changes here or there. And trying to basically get it so that the amount of time it takes to run the longer data set is about 4.2 times longer than the smaller data set. So like hoping that the time would scale close to like a 1-to-1 ratio with the size of the data file. So the original one was 3.2 times slower than it should have been. And obviously that's like at that specific instance, it's probably an exponential curve. So the larger it gets, that 3.2 times factor scales up more and more. And then I had gotten that down with my first revision to 2.8 times worse. So it got a little bit faster, but still, if the file size is going to scale pretty much close to infinitely or up to 18 gigabytes, if it takes 3 times longer than it should for a 150 megabyte file, it's going to take probably 20 or 30 times longer than it should for an 18 gigabyte file. So I was making a bunch of improvements on this, where basically like I would do this sort of revision and then run the time over and add it to just this like database. Funny enough, I asked ChatGPT to basically take my code and make this exact code block run as fast as possible. So I put it out what it gave me. It had some issues, so I had to go through and like fix the issues that the code ran because it just wouldn't run. But after debugging what it had given me, it ended up being the slowest out of all of them except for that first, except for like the very original one. But after all of these like 5 main revisions, the first revision ended up being the best based on the file size increase, which led me to think that this was probably as good as I was going to be able to get it. And so I had the idea of basically, rather than trying to run 18 gigabytes, run like break up that big 18 gigabyte file into like 20 equally sized 900 megabyte files. So hoping that those would process a little bit quicker and probably take maybe a couple hours to run rather than 6 days to try to run the whole thing, do a couple per day and like half the data set by the end of next week. So I basically had a way to just like kind of take it, break it up evenly, and then output it into like a folder here. And I think I knew that they would process because I had run a like 700 megabyte file in the past that took around 3 or 4 hours, I think, total to process. Maybe it was a little longer. So here's basically the files that it had broken up into. But the problem was that I was going to have to check it multiple times throughout the day and like really stay on top of like making sure it's always running something. Because if it takes 4 hours to run one of 20 files, that's still 80 hours total, and I need to be running at least 4 or 5 of those per day, so that I'm not getting behind. Like, you don't want to have a time where there's not one running, basically. But I was kind of concerned that I was going to have to need to get through at least 3 per day to make that reasonably run within a week. And I kind of come to the conclusion that it was still gonna take too long. Like, even if it takes 4 or 5 hours per one, I would like to have the data faster. So I went back to the drawing board on the code. And so I was using Shapely for this like distance calculation. And one of the things I ended up doing was like, what if I just replace this like distance calculation? Like, maybe it's an expensive calculation in terms of like processing power. What if I just replace it with the Pythagorean theorem? I know it's doing the exact same thing. So it wasn't that I hadn't considered using the Pythagorean theorem before. I just kind of assumed that the Shapely distance calculation would be more efficient, and maybe it is. Because for this iteration, I switched a couple things, but I came back and did one more revision. And I also switched from using like .unique to .groupby, which one of my friends was like, that's probably the main difference maker here. But I'm just going to pretend like it was using the Pythagorean theorem instead. but yeah, so I got basically from consistently around 20 to 30 seconds on the small data set down to 9. And then the biggest thing here is that it was taking me consistently where it should have taken, 4.2 times as long to run the big file compared to the small file. It was taking me between 11 and 13 times as long. But on this iteration, I think this is probably where the dot group by really came in handy. Because I think dot unique has to like keep running back through the code, and like checking over everything.
Yeah.
So that ended up probably was what the big time save was there, because I got it down so that it was only 4.3 times as fast or 4.3 times slower, and the file size is only 4.2 times bigger. So it's, just a tiny bit worse than like what a linear scaling would be. And that might have been just like this one particular example. So I have some Pythagorean theorem memes here. Average shapely fan versus average hypotenuse enjoyer. And then who would win? Some random Python package, not as cool, or the 2,400-year-old triangle math, which is very cool. But yeah, so I started running that over my 20 like partitions of my whole fall 2023 data set. And the first one took a little longer. For some reason, that file was just a little bit bigger. It might have been that there were just more people like in that space at that time doing move-in or whatever. But that one took around 19 minutes. But then after that, everything was between 13 and 16 minutes to run over a 20th of the data. So I could get through 4 per hour on average. So the full data set is now finished, which is cool.
All right.
I need to compile it into like one big data set still. I haven't had much time to actually like look at it yet. But I do have it. And so one thing that I was doing on Wednesday during one of our meetings was I just wanted to like check out one thing that I'm still really concerned with is this false positive rate. So basically the algorithm's trying to detect when these people are like having this interaction. But one of the like really difficult things is that if people move in this way that they've had an interaction but don't actually have some sort of interaction, this algorithm that I'm writing is like naturally going to probably pick up a lot of those. And so I'm concerned that I'm going to have a large amount of false positives, especially like around the elevator, around the base of the stairs. And then also maybe over here, because I don't normally see too much traffic in this area. So I'm surprised that it was returning so many collisions over here. But a lot of that might be Kevin coming outside of his office and like running into people and stuff like that. But yeah, so basically this was for 1/20th of the data set on average, which was around 6 or 7 days, I think. Maybe 6 days, would have about ranging from like 500 to 1,000 collisions on average. So coming out to around 100 per day, a little bit more, maybe 120, 130 per day. But one thing that I was looking at, I just wanted to like pick a collision and just kind of see what that looks like in our like animation data. So I didn't sync everything up perfectly yet, and that's something that I'm gonna plan on doing with a couple of these just to like really get that visualization down. But over here is basically all of the collisions that it had returned for like I think a 6-day period. And then over here is like the raw data. This is what like the LiDAR sensors are actually capturing. So I'll go ahead and play that. And so here's basically this collision point was the one that I was looking for. And it corresponds to this location in the space. So it's these two people right here, and I'll back it up so that we can like see that interaction a little bit more clearly. But it's gonna be hard for a collision to be a little bit more clear than that.
That's a good one. Yeah.
Where you just have these two people and they're very clearly they're coming from opposite directions. I don't know why it's playing in reverse. Yeah, they're coming from opposite directions. They even have either some sort of hug or handshake sort of interaction there. They chat for 3 or 4 seconds, and then the person who was walking that way keeps walking that way. The person who was walking this way keeps walking this way. So the one that I happened to look at happened to be like pretty much the perfect textbook case of like, this is what I'm looking for in the data. So I'm sure that a lot, and hopefully not most, but probably close to half of these points. We'll end up finding out, but I'm scared that a lot of these points are not going to be like that. It's going to be someone bumps into someone, or there's going to be some like small accidental like interactions and things like that aren't going to be quite so perfectly what I'm like hoping to look at. I think there's probably going to be a lot of false positives, but
I think that's all right. I mean, I'm really, but I remember the day that you detected your first collision, right, was super exciting, right? Like that was a staged one, right? That was like you and Shashank, like you did it in the data set, you manufactured the circumstance that you're looking for, and then but you were able to find it in the data, using your algorithm. That was great. And I think that this is similarly great, right? Like this is like you're able to detect, like you are able to detect collisions in the data set, like period. Like it is definitely happening. And then, there were always going to be false positives. And that's, those will get winnowed down with future work eventually, right? But even if you think of it like a second pass filter, right? Like if your filter goes through and like collects the ones that are probable, and then you have to make a second pass and then look at these in some other way and say, no, not that one, not that one, not that one, yes, that one. And you might have an idea on that in the coming weeks, right? Like you may have like I bet I could take these 800 or whatever they are. I mean, they're going to be a lot more than that for the whole semester, but I'm going to take this bunch of them that I detected, and I'm going to go through them one more time. And I think I can figure out what makes these real or not real. If you do, great. And if you don't, totally fine. But yeah, this is very impressive. That's a good one.
yeah, it just happened. I thought it was funny that like that happened to be like the best concrete example that I could have probably pulled out of every single one of these 800, and just happened to be the one that I picked.
Yeah.
But yeah, so that's what I have for. I don't know why that's playing now.
That gives you some sense of your odds as well, right? I mean, you could just be lucky, right? Like, let's say you had 30 false positives for every real one. Like the odds that you would have pulled your first one out, like you can make a pretty good approximation of how, like at best, I mean, you're probably in the ballpark of half of them are false positives, right? Or better, right? Like any more than that is less likely. So I think you're doing well.
Yeah, and I think I'd like to probably basically just repeat that process 10, 20, 30 times and just see like, here's this one, what's it look like in the data? Like how, on a scale of 1 to 10, just like subjectively, how ideal is that in terms of like in the raw LiDAR data, how likely would I say it's a collision?
That's a great way to do it. I think that's a perfectly reasonable way to get a back of the envelope false positive rate estimation. Yep. Cool.
Yeah, just to see kind of what I'm see what I'm looking at there. But yeah, so my goals for next week, I want to finish the like detecting collision section in my thesis document. And I don't think that'll be too tough for me. Or at least finish like the first pass through it. And then the part that I'm super excited about is beginning like the exploratory spatial data analysis on the collision data set itself. So basically taking all 20 of the little parts and putting them into one, calculating like specifically what hour of the day they're happening in, what day of the week the collision happened on, and then taking those and like bidding them up and seeing, which day of the week sees the most collisions on average, which hour of the day sees the most collisions on average, and like getting charts like that. What's the trend as the semester goes on? Is it positive? Does it just kind of, waver back and forth? So that's part I'm like really interested in seeing, because like we've been working on this project for a while and I haven't actually had the chance to answer any of those questions yet. So now I'm at the part that I can at least kind of start to answer that. And have a decent idea. Even if they're false positives, you would imagine that the false positive rate is consistent throughout the time, that like August isn't going to have 4 times more false positives than November. They'll at least be similar in theory. I don't want to fully make that assumption, but
right. Yeah,
probably safe to assume for now.
Probably right, possibly not. Yeah.
And then also just doing a little bit of like spatial analysis. So like where are collisions the most frequent, where are the least frequent? Kind of compare those to like the zones shape file. I think I made that. So I think I should still have that somewhere, and seeing like, which parts of the building have the most And then if I want to go even further, like at what times are they more frequent in this area versus this area? But yeah, so that's what I have for this week.
Awesome. Cool, good work, good work. Do you guys have any questions about especially Zhenjiang, which is the first time seeing this sort of indoor LiDAR project? Shashank's kind of working on detection and Addison's working on collisions.
Oh,
Like
got it.
2 people running into one another, having a conversation and then
Yeah.
going on their way.
It's like to detect the interaction between people in an indoor environment. I think this is cool.
Yeah, thank you. I like it. We on Wednesday of this week, no, Thursday, yesterday, one of like the faculty candidates was visiting for Virginia Tech for like one of the open positions. And she was doing some like GIS, very like statistically heavy stuff. But there was like a little luncheon after her like seminar. And so we got to like everyone got to like introduce themselves and whatever. And so I had like mentioned my project just like in passing, and she was like, "That's a really interesting project. I've never heard of anything like that." And I was like, "Yeah, we have like a building on campus over there. We got some LiDAR sensors in there." And she found it fascinating to say the least, and like it's definitely very unique.
Cool, cool. Maybe she'll be a good collaborator on the project kind of moving forward. If she's got an interest, that'd be great. Oh, if she gets hired.
Yeah.
Four candidates is what I heard. Is that right?
I think
Yes. I
3 in
think,
person, 1 on Zoom.
Yeah, coming in person and
Oh,
like
this is
one is
Zoom.
also Zoom. Yeah.
mhm.
I had met the candidate at like ASU when we were presenting the digital twin stuff. So yeah, so it was a good interaction yesterday too.
Yeah, great. Cool. All right, well, we'll wrap things up then. Shashank, why don't you stay on the line for a little bit? We'll just talk through some of the sampling stuff so we don't lose any time there. But all right, thanks everybody.
Do you need to see me at 2 today or?
Yeah, 2 today.
2 today, okay, I'm sure.
All right, see you.
Have a great weekend, everyone.
Yeah, have a good weekend, guys.